Good afternoon, pre-calculus students. Today we're going to be looking at ellipses. So let's go ahead and look at a picture of an ellipse and how it is formed. Alright, so if you remember from last week, here is a diagram of a conic, and you might be remembering that an ellipse is formed when I take and I have a plane tilted such that it will go through both generators of one nap, and that's how I create an ellipse. You notice inside this box I've got that definition of an ellipse. I'm going to let you go ahead and read that. You might notice as you're reading this definition of an ellipse, okay, that ellipses are going to have two foci, right? So let's look at another diagram of an ellipse, okay? At home, you can actually create an ellipse quite easily using just a piece of cardboard and two thumbtacks along with a piece of string. And that's what I've done here. All right. You'll notice I've got my two thumbtacks and attached is my string. This string remains a constant distance, and I'm able to trace it all the way around and create my elliptical shape. Okay. These two thumbtacks are representing my foci because I have more than one. And the foci are going to be located along what is called my major axis. Okay, this is my major axis, which happens to coincide with my x-axis at the moment. This axis, this dotted line I've drawn for you, it represents the minor axis, which is the axis that is perpendicular to my major axis. The other point I've noted here is the center. Okay, the center of an ellipse is equidistant between my two foci. So it's that midway point between the two foci is where my center is. Okay, so you can imagine I can have an ellipse that looks like this with my foci along this major axis coinciding with my x-axis, or I can actually have an ellipse that looks like this where I'll have my foci more in line with what would be the y-axis. In this case, the y-axis would behave as the major axis, and my minor axis would now be the x. So really the position of the foci are going to be really important to us. So kind of like we did with the parabolas where we had to think about where my vertex was, with an ellipse I need to think about where's my center and where are my foci. So let's take a moment and look here at this situation. Here I have an ellipse with a center of 0, 0, and now you'll see I have my two foci, and here I have what I call my vertices. Okay, the vertices are going to occur on the major axis. Right, the minor axis here, since this is along the x-axis, the minor axis really is, I would find that value as it's really the y-intercept. Okay, this is the y-intercept. Now, the equation of an ellipse is determined using the distance formula, and I'm not going to derive that for you here this afternoon. However, in section 9.3, it does show you how these equations are derived. So if we look at this together and we looked at it from an equation perspective, let me get the glare off of there, you'll notice that x squared over a squared plus y squared over b squared equals 1. That's the equation of an ellipse that has its major axis as the x-axis, and it has a center of 0, 0. Okay, if I look at my an ellipse with my major axis being the y, notice the focus and the vertices lining up there, that's how I can identify that, then my equation is slightly different. It's x squared over b squared plus y squared over a squared equals 1. Now you might be wondering, what is a squared and what is b squared? Okay, and that's what we're going to look at next. Okay, I do want to make this point though. Any ellipse that has a center of 0, 0 will be symmetric about the x, y, and origin. Symmetry. So in order to graph an ellipse, you need to know 4 points. That's all you need to know, 4 points. Because it's going to be symmetric. I suppose you could argue you just need to know 2. And then you'll know the others due to symmetry. Okay. So let's look a little bit more in depth at an ellipse along the x-axis. Okay, so this is what I have drawn out for us here. I think you can see this okay. So my vertices positions are described as a, 0. A being the distance from the center to the vertices. Okay, notice symmetry. A0, negative A0. My distance to the foci, okay, from center to the foci is described as C, okay? Again, symmetry. So my two focuses, if I know one, I know the other. I have the foci are going to be located at C, 0, or negative C, 0. My y-intercept, the key here, okay, if I want to know this y-intercept, I cause x to be 0. When I make x 0, okay, from my equation up here, this has gone away. Bye-bye. It's gone because it's 0. Then I have y squared over b squared equals 1. And therefore, y is equal to plus or minus b. All right? Those are my points, okay? That's going to always be the case. If I not really reverse it, but if I look and have my major axis along the y-axis, okay? Notice what's happened here. My vertice now is 0a, right? Because now I'm going up and down, okay? My x value staying the same, 0, and my y value is changing, okay? So I now have 0a, and my other vertices would be at 0, negative a. Thinking symmetry. Foci, same thing. We're going to use C to describe that distance. Now my position is 0C, and my other is 0 to negative C. In this situation, instead of finding my y-intercept, I need to find my x-intercept, because that's where this is going to cross. It's going to cross at the x. Okay? So I make, in this case, I make y. I make y 0. This goes away, and I think about x squared over b squared equals 1. If I follow through the math, then x is going to equal plus or minus b. That provides for us the basis of the vocabulary needed in thinking about ellipses. So, as you watch the next 2 videos in preparation for Wednesday's class, really be thinking about the words foci, vertex, and whether or not you're thinking x or y-axis as your major axis, because that's going to impact your equation.